Hey, thanks for the introduction, and good morning, STC. Great talk by Rishabh. I have a tough time matching up to the talk that he did. So, STC 2016. STC 2016, we were one of the exhibitors here at the same venue. And it's been quite a journey since then for pCloudy.com. And for some of you who do not know about pCloudy.com, please visit our booths to know more about it. It's one of its kind autonomous device testing platform. So I'm extremely proud today to be one of the event sponsors to the STC 2018 edition, which I can truly call it Mecca of Great Indian Testing Minds. So good to see you all, and so good to see a full house here. So today morning, when I was getting ready for the session, I picked up my watch, and I saw an interesting notification, which I think is worth sharing in the context of what we are discussing today. And the notification read something like this, that congratulations, you have been meeting your activity goals from last 2 weeks, so keep it up. And your goal has been increased from this week. And it got me thinking, the device could have taken two different routes. One where it could have just asked me to set new goals. But in this case, based on my past behavior or patterns, it decided a new goal on itself. It was courteous enough to ask me whether I want to accept it or not. But it did show a brain of itself to be able to take intelligent decisions for me. And isn't AI all about machines displaying some brain so that they can take intelligent decisions for us and make our lives useful? So I'm sure you all would have experienced AI in some way where machines, device, or tools that you are using are showing some intelligence around all of us. But when it comes to AI in testing, probably the picture is still not very clear. And this is based on the interactions that I have had so far in the last 2 years, talking to organizations and people. So the picture is still quite hazy, probably like the image that you see here. I'm not sure what the painter is trying to draw. Maybe it's an egg, or it's a potato, not sure. But as soon as the painter flips the picture upside down, it becomes absolutely clear. So hopefully by the end of session, we'll get a better picture of what's the role of AI in testing, and you would be able to relate to how, why, where of AI in the world of software testing. But what's the Tesla connection here? Let's get that out of the way first. I'm not sure what comes to your mind when you see this image. Maybe just wow, or maybe you want to own it, you want to ride it. So I've been following Elon Musk for some time, and by virtue of it, Tesla as well. And one word that comes to my mind when I think about Tesla is the word called reimagination. So while the whole world was busy, or the whole of the other world was looking at cars as a combination of electronics, mechanics, and a bit of software, Tesla completely reimagined the car as a sophisticated computers on the wheel. So their cars are connected to a central cloud through which they can push new features, they can fix problems. So very recent news that you would have heard, they had a brake problem which they could fix completely remotely. So they have changed the way the whole auto industry is now looking at design of the car. And that, with that, I would like to pose this question in front of all of you. Is AI forcing us to change or reimagine the future of testing as we move along? So with this perspective in mind, I would start the session a little differently. I am breaking a few rules here. Probably you can just pull out your phones, open your camera application, and just point to the screen. Maybe you'll have to zoom it a bit. And since there is no internet connection on this machine, I am managing this poll from my phone. So once you point out to the screen, you'll see a small badge or a pop-up or a notification. Just click on that notification. You will be directed to a page where it says the poll is about to start. So I'll wait for a few, maybe 10 seconds before you're done with scanning. So if you're done with scanning, I'm moving to the first question here. Hope you all can see the question. This question is just for me to understand the demographics of the audience, because that will help us pace the session. So just enter the options that you see for the question. You would have got the question on your phone using the link. And I would be able to see the result live on my phone as well. I cannot show it here because, again, switching between the screens is a little difficult. So I can see, in fact, you have moved to the next question itself, which is the essence of the question that I wanted to check here, to get a perspective from what's the level of AI adoption within your organization. And I have the result in front of me, which says almost 20% of people have started using AI in some way. That's fantastic. There are some proof of concepts happening for around 17% of the organization. And almost 50% are planning to use in some time, where almost 20% have not planned it yet. So that kind of gives us a breakup of where the situation is as far as AI adoption within organizations are concerned. And the organizations probably present here. Now, I would like to link this analysis to a more structured research which has been done across the world. And what you see here is called the normal distribution of innovation diffusion, a complex term, but in a very simple way, what it shows is how new technologies or new innovations are adopted across the world. And just focus on this red block here, which kind of gives you a sense of how many people are adopting newer technologies as they arrive in the market. So some of innovators and early adopters are just 16%. So in that sense, the survey result that we got is better than the graph which is shown here. And rest of it, which is almost 84%, either wait for some references or some industry standards to get evolved before they start using any new technology in the market. And why this is important, I'm throwing some more data here. And there are familiar names like Amazon, Netflix, or LinkedIn. And one key data point that I want to highlight about Amazon is it does almost 50 million code releases per year. That's more than 1 per second. In case of Netflix, they have only 16 minutes of commit to deployment time. Staggering figures. Same is true for LinkedIn. And what it kind of gives an indication is the kind of gap that exists between these organizations and some of the other organizations in the world. And there is a common pattern for the three names that we have mentioned here, is these companies fall in the first category of 2.5% that we talked about. These are the innovators who have been able to adopt technology faster than others. Now, with the advent of AI, my personal belief is this gap is going to increase between the innovators and the rest of the world, because AI is changing the world so fast. And the tagline kind of depicts the situation very clearly. This is a tagline by brand Jeep. You might have heard about it. Don't follow me. You won't make it where I'm going. So in case of AI adoption, you have to think about riding the wave, and you shouldn't become a follower. So with that perspective set here, let's move to the crux of discussion. What's the role of AI and how AI is transforming testing and how it's going to be used. And just a little bit about some terminologies, some quick definitions. So we all know AI is a technique which enables machine to mimic human behavior, while machine learning is a subset of AI which uses statistical methods to make sure that machines are learning on its own and predicting on behalf of us. Now, what I'm going to show now here are some basics of machine learning and a five-stage process through which any machine learning system is designed. There'll be some technical jargons here, but bear with me. I'll try to keep it as simple as possible. So in the five-stage process that you see here, the first is where you collect as much data as possible using which you are going to build your models. And then we move to the second stage where we categorize the data, we clean up the data, and we structure the data so that the models can understand. And at the same stage, you also categorize the data between kind of training data and a test data. So large majority of the data will be training data which you will be feeding to your models, and some percentage of the data will be used for the testing part of it, which is the fourth stage. So we are talking about majority of structured data here with some categorization already done, which leads us to step 3, where we are going to expose the data to the model. And in this phase, let's take an example. For the sake of example, I'm taking example of fruits. So let's say I'm building a model to classify fruits. So if I feed a data which has certain characteristics about fruits, I can tell the model to recognize it as, let's say, fruit, as an apple. Another set of data which has different numbers, I can tell the model to recognize it as an orange. And that's how you train the models. And the best part of any machine learning algorithm is that it starts building patterns on its own based on the data that you feed. And those patterns are used to then predict when you feed the next set of data. So now that we have fed apple and oranges, we move to the test data. And when the test data is presented, let's say a different shape of apple with slightly different texture, maybe the model, because it has now built the patterns, will be able to recognize this as an apple again, which is perfectly fine. But what if I feed this? Probably because the pattern is same, this image also will be recognized as apple fruit, which is not right. And that's where the testing and improvement happens. So maybe now you need to add more data points within your models or more characteristics on your ML algorithm so that this particular image is recognized as logo, not as a fruit. So that's kind of summarizes the overall machine learning process which is followed to create machine learning systems. Having kind of set the tone for how machine learning systems work, now let's talk about AI in testing. And that's the crux of discussion that we want to have today. So for this, so there are numerous examples where we can use machine learning, and some of it was mentioned by Resav as well in case of SAP. But I have picked up 3 different areas, and I'll try to show you certain practical examples of how we have used AI in 3 different areas. The first is visual verification. The second one is predictive issue detection. And the third is creation of bot in itself, which can do a lot of manual tasks, which can take up a lot of manual tasks of the test teams. And since my focus is in the area of mobile apps, my examples are also related to mobile apps, but you can link it with any kind of apps that you are working on. The fundamentals remain same. So let's start with the first one, which is visual verification part of it. And I'm sure you all agree, visual verification has been a missing element so far within test automation. So with the help of test automation, all the functional, performance, security part has been automated. But when it comes to visual verification, that is still largely done through humans, and it takes a lot of efforts. So the question is, can we bridge the gap and bring automation to a level so that it can start acting like humans and start doing visual verification as well? So can AI help here? And let's see how. Now what you see on the screen are kind of a bunch of line of code here. Would not make sense right now on this screen. But just to set the context, this is an Appium script, Appium JavaScript, which we have written to do a visual verification of a mobile app running on a real device. So for the sake of simplicity, we have just picked up one screen of the mobile app and written this piece of code, which can be used to do visual verification. So let's take it step by step here and see how it works. So as part of any visual verification, the first step is you need a baseline using which you can compare and say whether the new set of application is matching or not. That's what a human does. He has probably the baseline lying in his computer as a screenshot or in his mind, but you need a baseline. So what we are doing as a step one is uploading a baseline image, and the baseline image looks something like this, which is a sample mobile application by pCloudy. So it's the first screen of this application, license confirmation page. And we are uploading this image to a machine learning server. I'll talk about that machine learning server a little bit later, but just for the time being, let's assume that this is being uploaded to a machine learning server. Then we move to the second stage, which is, if you know Appium, this is a familiar statement, where we are taking a snapshot of the application on the device at the runtime. And then we are uploading the same image in the second line to the same machine learning server, right? So that now the comparison can happen between the baseline and the new screenshot. And this is what the new screenshot looks like, which has been taken on a Samsung Note 9 device at the runtime. And this script can be run on any device in parallel, all that is possible. In third step, what we are doing is asking the machine learning cloud to give us the analysis of this image. And this analysis looks something like this in form of a screenshot. But then you here, in case of script, we are taking a JSON response, which will be used for the verification purpose. But you can see the machine learning algorithm has very nicely broken down the image into various blocks. And each block then has a lot of properties built inside it, which can be then used to compare. And the best part of the machine learning algorithm is you can actually define your own blocks. So right now, this has been created with certain pre-trained models, but then you can build your own models so that you can define the image with certain different kind of blocks depending on your need. So for example, if your application has a lot of images, you can train the machine learning algorithm to identify images with labels together, or maybe images and labels differently. So all that is possible. But for simplicity purpose, you see a categorization of the image in certain kind of blocks, and each block has its own property, which is used in the last step to validate different labels that you saw on the screen using a simple comparison function. And what you see as a result is, which is highlighted in the red, is there is a mismatch in the alignment of the accept label. And if you would have noticed the screen slightly carefully, the accept button in Samsung Note 9 was misaligned, which it has detected. So that's just one example of it. You can probably enhance it to show it, show the differences itself in much more UI format. The result is more textual, but that's more of a reporting part of it. Now, all this has been done by someone who does not know any machine learning within probably half a day. And that's possible because there are so many resources available on the cloud which you can use to start building something like this within your context. And what I'm using here is a Cloud Vision API by Google, which provides pre-trained API model for image analysis. and you can try it right away, right now, opening your phones. It works beautifully. Now, the best part that I was talking about is this machine learning algorithms also allow you to train your models differently, depending on what kind of verification that you want to do. Now, at this stage, you might be thinking, I cannot use something like a publicly available because that's not allowed in my organization. I'm not allowed to use external Google APIs. But to make the life simpler, similar resources are available in open source world, which you can collate and build something like this internally, which we have done within pCloudy to do a real-time image comparison and provide differences. But for the audience, you can start using something like Google API to understand and learn and see how things work. So that was about visual verification. Moving on to the, I'll skip this part. Moving on to the next part which I wanted to focus was the predictive analytics. And again, the example here is in the context of mobile apps. And some of you, if you're testing mobile applications, big challenge is testing on so many devices, permutation combinations. It's a huge effort. How can we minimize it is one big challenge everyone is asking for. When we talk to customers, they say, okay, you have so many devices, but how many devices should I use for testing, right? That's one question. That's one prediction customers are asking for. So the question that we started thinking was, how can we predict the failures of the application on the devices? Can we give certain information to the customers that they can use to optimize the effort, and that information could be in terms of where the asking, or the question that customers have been asking is to provide certain analytics in terms of device coverage, in terms of where my applications can fail. Can I know? So while I'm building the application as a developer, can I know where the application can fail? And that's what predictive analytics in this example will show you, using the same AI technique that we talked as part of machine learning journey. So what you see here is a screen from pCloudy where typically you upload your application on a device and start testing it manually. pCloudy can be used to run automation scripts also, but this is the screen where you test your application manually by uploading it on a device. So what you see here is a VLC application installed on the device. And on the right-hand left corner, you see a small bubble. And as soon as the application is installed, it starts running certain tests. It starts figuring out where the application can fail. And something like this happens. So there is a suggestion bot that appears, which tells you where this application could fail. So you are testing it on probably Google Pixel, but it says a possible failure on Amazon and SS devices because there is a decoder issue in this application. A possible failure on Samsung LG device because split window mode not supported. You might not understand this because it's a little technical in terms of why these failures are happening, but the key point is it's exactly predicting where you should test rather than testing next on a, let's say, a Apple device. You should first focus on testing it on a Samsung or LG device, or there is a sure shot failure on Amazon SS device. So it's not only helping you predict where should you test, it's also helping you predict which test case you should focus on. So here it says you should test it on a split window mode on a Samsung device. That's where your failure is going to be. So just imagine the time it's going to save for organizations in terms of planning their testing. And it's so useful for developers. They commit a code, they can just run this test and figure out where the failures could be. And this is not something which is very difficult to build. It requires a lot of effort for sure. This has been built using the same technique that we talked about, the 5-stage process that we talked about. And what we have been doing over a period of time, because we are a mobile app testing company, we collect a lot of data around where the bug failures are. So for example, this is one sample database that you see, which says, if you are using an API level 26, and if your application has a language change feature, there is a OS compatibility issue, and it's going to fail on all devices as soon as you make a language change on the application. That's a sure shot failure if your application is using something like API level 26, right? Now, the bigger the database is, the more accurate the results will be, right? So the whole process here is build that database, which we are building, and hopefully in very near future, we are going to make this database open source, because we believe that the database can be bigger if the community contributes to it. We can't build this database completely on its own. And then, based on this database, there are certain models which has been created, and those models are applied to apps to predict the failure. Exactly the same steps that we discussed about. That covers the predictive part of it. And the third is the bot, which is the culmination of all that we discussed. Here still we are talking about giving some inputs to the device, or a human has to at least perform certain steps. But can we build certain bots which can take up a lot of our tasks and help us focus on our core jobs, right? Again, the example is in the context of mobile app. So here is a bot which expects the application as an input, and there are certain data inputs which are required. So for example, if your application requires certain username, passwords, maybe phone number or OTP, you can pre-configure that data point inside the screen that you see. And once you provide this input, you just sit back and relax. And the bot will, based on the patterns or the models that we have built, will start mimicking the user behavior and start testing the application completely on its own. And once the test is done, here you can see a kind of test result. I'm not sure how clear that is, but you can see certain graphs at the top, which talks about what's the quality of the application in terms of its health. So what's the CPU rating, what's the memory, battery, network. And then this test has been run on 10 different devices within a very short period of time. And then you have result on each device, and you can compare the results here itself. And if you just move on, you want to drill down, you can see more insights which has been found by the bot, again using the predictive technology, and followed by a detailed report on each of the device. So you can see all the different charts, like CPU, memory, frame rendering, and all the screenshots which has been captured to let you know what flow has been executed. So now we have seen this bot being used in a lot of scenarios where there is a quick sanity to be done. A lot of times, any new release that comes, you are asked, can you do a quick sanity? It's the same job. Maybe you automate it, but the automation also fails. There are UI issues. But with bot, because it's taking the runtime application as an input, and it has pre-configured or patterns, it uses the latest build, so all the UI changes and etc. does not matter. It does everything at the runtime. So the chances of success here with a bot is much higher than a traditional automation-based solution, right? So there are a lot of people who are already using it for their exploratory test or sanity test. Now, as the bots are evolving, there are more and more algorithms which are getting added, more and more patterns getting added. It can be used for much more extensive testing, right? So a lot of these standard repetitive tasks can be handled by the bot, and the QA teams can focus on core areas of making sure the critical functionalities work, the corner scenarios work, while the rest of the tasks can be taken up with the bots. So we discussed about 3 different scenarios: the visual verification, predictive analysis, and bot as a system to help you do testing. But there are many more areas. I picked up those scenarios because we do that work as part of mobile application testing. But there are many more areas that you can explore. So areas in test management, where you can optimize the number of test cases that you have to use for a particular release based on certain analytics that you would have drawn over a period of time. So draw that analytics, build certain models, and these models are very easy to build. Let me be very upfront. There are enough open source projects available which you can use. Another area, automation. So one, visual verification part we talked about, but then there are a lot of self-healing, self-learning automation being created. So if there is a UI change, the AI can learn on its own and then modify your automation scripts. So that's the automation piece. Optimization of test cases, again linked to the test management part. Impact analysis is a big area where AI can help. So for example, if there is a particular change in an application, it can detect what are the impact areas. Again, very simple, based on certain models and patterns that you can very easily create. And UI testing, we talked about. So with this perspective in place, I'm not sure where do you see right now yourself in using AI for the future. I can tell you that in last 2 years, we have done some groundbreaking work, starting completely from scratch, right? So I believe each one of you can start looking at AI as your buddy, not as a threat. It's very simple to learn and start thinking of your use cases that can be done through AI. So now, to end the session, I'm asking the question, so STC, are you willing to say, hey Certifier, can you test my app? Thank you so much. So we are present at booth number 1. If you have any detail, if you want to know more details about what we talked about, we'll be more than happy to answer and talk more about it. Any more insights that you are doing, which we can use, we'll be more than happy to share and discuss. Thank you so much. It's been a pleasure discussing the disruptive technology with all of you. Thank you so much. Hope you're having a good time. I'll be repeating few of the stuff which I talked about in the morning. So some of you who saw the keynote will see some of the similar stuff. So just to start, pCloudy is an autonomous mobile device cloud, and we are doing some cutting edge stuff to take mobile app testing at the next level. So I'll let some of the initial slides run through and then we'll talk about it. So QA has been laggard for some time in terms of adopting newer technology. We have relied far too long on traditional approaches. And unfortunately, the tools that have been there in the market have been inefficient, leading to delay in your testing cycles. And but the situation right now is that everyone is asking for quality at speed. You can't have a trade-off between quality and speed in the current situation. So what we need is a way to change the status quo, to change the traditional approaches that we have been using. And that's where pCloudy comes in. We are a bunch of dreamers. We are taking up the challenge to change the status quo as far as mobile app testing is concerned. So pCloudy is breaking the status quo with simple tools powered by technologies of the future. And some of the technologies I talked about in the morning, AI and predictive analytics. So coming back now to the product and what exactly are we doing. So we are disrupting the mobile QA with next-gen tools which are pre-built within pCloudy. Let's look at some of those tools at a glance. We call it our next-gen features. So in terms of changing the status quo, a lot of organizations are still relying on physical devices or emulators to do their mobile app testing. That should change. A company like Facebook has set up a data center of 2,000 devices where they test their application as and when the commit happens. So that's the next game we are looking at, where you have to move from the physical devices, from your physical labs to a cloud-based lab. And with pCloudy, you get a device infrastructure at single click. And it comes in multiple flavors. What you see, the screenshot is from our public cloud, but we have other flavors where we can set up a private cloud hosted, dedicated for a client, or an on-prem cloud which can be hosted inside your organization premise to create an internal cloud. So depending on need, you can choose one of the offering, but the key aspect is you have to move to a cloud to bring efficiency within your system. So device infrastructure at single click is one of the, I think that LED screen has a problem with me. Yeah, so device infrastructure at a single click is one of the key features that we provide. And when it comes to accessing the device, again, you can access the device like any other, like the way you access the device when it's in your hand. Pretty much you can do all the stuff directly from your browser. So you can see one of the screenshot here of this device, Google Pixel. And on the left hand side, on the right hand side, you see certain graphs and icons. These are the tools which you can use during your testing on a particular device. So things like taking a screenshot, logging a bug directly to Jira, capturing the performance data of the application when it's running on the device. All these features are available at one single click. And just to kind of add one more point, on the device you can test both your app and mobile web, native as well as hybrid when it comes to app. The second feature that I wanted to highlight is, why do you want to compromise on time taken for testing when it comes to manual way of testing? Still a lot of testing happens in manual way. So we are giving a breakthrough features where the manual testing can be done in parallel on multiple devices. That's the feature which is called Follow Me. So what you see here on the screen are 3 devices in the same screen. And if you perform action on the device which is in the center, it gets replicated automatically on the other devices. So what would have taken probably, let's say, 3x time can now happen in 1x time with this Follow Me feature. And we are going to extend this to more device in one screen. The only challenge is how do we fit it in one screen? There's no technical challenge as such in front of us. So this is one of the breakthrough feature which you'll not find anywhere else. It just exponentially increases your testing efficiency when it comes to manual application testing. The third feature I wanted to quickly talk about is the struggle with parallel runs when it comes to automation. So I'm sure you spend so much time creating your automation scripts, but unless you are able to use it on multiple devices together, you can't get the result that you are looking at. So automations at scale is what the next level game is all about. And pCloudy gives you that power of automations at scale. So what you see here is one snapshot of a dashboard where this test, automation test was run on more than 40 devices or 50 devices together. And there's no limit to number of devices that you can select. You can run it on 100, 200 devices which are available on the cloud. And same is true when you set up either a private or on-prem cloud. So the point is, you have to look at automation at scale to get the real ROI of the automation effort that you are putting in. And here it's provided seamlessly, again without for you to write any line of code or to build any new integrations. All that is possible at a single click. And just to add one more point, pCloudy in terms of automation tools supports most of the popular open source tools that you might be using. Tools like Appium, Espresso, XCTest, Calabash are by default supported. Some of the newer tools, if you like to integrate, we have open APIs which you can use it to integrate within within your frameworks. Moving on, the next feature is DevOps. So just the session that you were part of was all about DevOps. So mobility projects in general are agile and DevOps in nature, but that's where you get the speed and efficiency. And you don't have to wait to create a DevOps story for your mobile application. pCloudy comes with a lot of pre-built plugin as far as the DevOps integration are concerned. So what you see here is a default plugin for Jenkins. So just install the plugin, create a job, and connect it to pCloudy. So your automation scripts can run directly from your Jenkins on multiple devices. In parallel, you get the result back in your Jenkins dashboard. And then you can create your Jenkins pipeline accordingly. So all that is again possible at a single click. So these are some of the key features which exist. And on top of that, I was talking in the morning that we are adding little brains to the tool. What you saw are mostly the regular features that you see elsewhere as well. But we are adding little brains to the tools to take pCloudy to the next level and disrupt the mobile application testing. So one of the features that I talked about was AI-powered bot, which we call it Certifier. And Certifier can be used to do a quick exploratory or a sanity test within a very short period of time. So what you see here is a test which has been run on almost 10 devices within probably 10 minutes or 15 minutes. So just push the application to Certifier, and Certifier takes care of all the testing which needs to be done on a variety of devices. And if you notice, if you can see the dashboard here, all the devices are selected are of different configurations. So within a short period of testing, you get a complete range of device coverage. And this can be extended to more devices as well. So without writing a single line of code or a script, you are getting a comprehensive testing or a health check of your application within a very short period of time. And the last one, which is one of the key features that we are working on, it's a work in progress, and I talked about in the morning as well, is predictive engine to improve accuracy. So this is where we are predicting the bug failures based on the machine learning and the database that we have created. So whatever applications that you install within pCloudy, it will scan, it will analyze the pattern, and will be able to tell you where else the failures could be. So this way you will be able to kind of minimize the number of devices that you need to look for testing, and also kind of minimize the number of test cases that you have to execute. So are you excited to try pCloudy? But do you have any doubt in terms of who are using it and what's the validation of this? So we have close to 5,000 browser and mobile device combination on our public cloud. More than 50,000 plus users across the globe are using the platform, and the number is increasing every month. 200,000 plus device hours have been tested on the platform, and that's just the public cloud stat. This does not include private cloud or the on-prem cloud data. We are one of the highest performer rated by our users on G2 Crowd, which is one of the trusted crowd review platform. We have been covered by Gartner and Forrester analysts in their reports. So you can go through those reports and read about what they say about pCloudy. And some of the key customers who are using. So we have, some of you might be present here as well. So we have Wipro, Genpact, Hexaware, Accenture, Max Life, Honeywell, and there are more names getting added as we speak. So we are working with companies ranging from startup to large enterprises, global MNCs at the same time. And in a very short period of time, we have the benefit or the privilege of getting validated by top SIs of the world, and they have made us partners. So we are working with Infosys, Capgemini, Hexaware, UST Global, Mar Labs, and they are our global integration partners. So they are taking us to their customers, and that kind of validates the kind of product that we have created and the kind of innovation that we have done in a very short period of time. So with that, I would like to close the presentation, and if you have any question, feel free to ask, or we are there at the booth. Thank you so much. Thanks for listening to me again.
Thank you so much, Mr. Avinash. I'm sure they will be able to contact you outside at your booth.